Students, today we are going to discuss remaining Z transform properties, that is differentiation of X of Z. It states that n into x of n Z transform is minus Z dx of Z by dz, and also reason of convergence is R of X. We are going to prove this one. Let us consider from the definition of Z transform what is X of Z. X of Z is equal to summation n is equal to minus infinity to plus infinity x of n into z power minus n. Correct? I am going to prove that one. Further, I am going to consider the RHS of the given statement. So minus z dx of z by dz is equal to, how will get d by dz of x of z? Already we know x of z by differentiating x of z with respect to z. So minus z. So I am differentiating x of z expression with respect to z. So minus z into summation n is equal to minus infinity to plus infinity. X of n is not in terms of z. We have to differentiate only the z power minus n. What is differentiation of z power minus n? Minus n into z power minus n minus 1. If you simplify that expression, that z and this z, if you combine means we'll get it summation n is equal to minus infinity to plus infinity n into x of n z power minus n. Now you compare the definition of the Z transform expression and the given expression. What is the difference? Have you understood? What is the difference? Have you seen in these two expression? Only one difference. What is the, from the definition of the Z transform, we have the input signal x of n. What is the signal here? N into x of n. So we can write it. This is the Z transform of n into x of n. That is only our LHS. We consider RHS. We got LHS. The statement is proved. Okay, differentiation of x of z property is proved. Now we'll see the next property. What is the next property? Conjugation of a complex sequences. Correct? So it states that x conjugate of n Z transform is x conjugate of Z conjugate, and also reason of convergence is R of X. Okay. Now we are going to prove it. Let us prove. Okay. Consider from the definition of the Z transform, what is x of z? Summation n is equal to minus infinity to plus infinity x of n into z power minus n. Correct? Now I am going to find the Z transform of the given statement. What is the given statement? We have to find the Z transform of x conjugate of n. So substitute in that Z transform expression. What will get? Summation n is equal to minus infinity to plus infinity instead of x of n, x star conjugate of n z power minus n. Correct? Now I am going to apply two conjugates. So that is, if you two conjugate, if you apply both conjugate, will get the same. So nothing will differ. So for simplification purpose, I am going to apply two conjugates. So that is summation n is equal to minus infinity to plus infinity x conjugate of n z power minus n conjugate, and then whole conjugate. The first conjugate I am going to combine with x of n. So the here summation n is equal to minus infinity to plus infinity. X conjugate of n into conjugate is nothing but both conjugate will get cancelled, only x of n. If you combine that conjugate with the x z power minus n, will get z star of minus n, and then the final last whole power conjugate. So now this is in the form of if you compare the definition of Z transform expression, x of z expression, and this expression, we can conclude that this is Z transform of x of n, and instead of z we have z star and also conjugate, so that we can write it as x conjugate of z conjugate. Correct? That is only we want. So we proved. Okay, understood. Then we'll go to the next property. What is the next property? Time reversal. It states that x conjugate of minus n z transform is x conjugate of 1 by z conjugate, and also reason of convergence is 1 by R of X. This is the time reversal property statement. So now we are going to let us consider R of X. R of X is not the reason of convergence is between Rx and RL. Same thing, if the R of X reason of convergence is in between Rx and RL and Rx, same thing 1 by Rx is in between 1 by RL and 1 by R. Okay, clear. Now if x of n is a real r, we do not conjugate. We should not conjugate x of minus z. Only the odd signal, only the complex signals. So x of minus n z transform already we know x of 1 by z, and reason of convergence is 1 by r of x. Correct. This time reversal property I am going to explain with example. Let us consider x of n is equal to a power minus n into u of n is the one signal. What is the z transform of a power n into u of n? That is 1 by 1 minus a into z power minus n. I want x of n already. We consider x of n z transform is x of 1 by z. So that is reason of convergence is 1 by x. So if we combine these two, we'll get it x of z is equal to 1 by 1 minus az, that is equal to minus a in a power minus 1 z power minus 1 divided by 1 minus a power minus 1 into z power minus 1. So this is the time reversal property. Now we'll go to the next property is convolution property. Convolution of two sequences. Let us consider the statement x1 of n and x2 of n are the two signals. The convolution of the two signals, that is x1 of n convolution x2 of n z transform, is multiplication of their z transform, that is x1 of z into x2 of z, and also ROC, reason of convergence, contains Rx1 union Rx2, where Rx1 is reason of convergence of the first input signal x1 of n, and Rx2 is the reason of convergence of Rx2. The convolution of these two signal z transform is multiplication of their signals, and also ROC is union of the two ROCs. Correct. Now I am going to prove it. Let us consider y of n is the convolution of the two input signal x1 of n into x2 of n. Already in the first module we discussed convolution sum. Convolution sum is nothing but summation k is equal to minus infinity to plus infinity x1 of k into x2 of n minus k. Correct. Now I am going to write z transform of y of n. Z transform of y of n is y of z. Summation n is equal to minus infinity to plus infinity y of n into z power minus n. Now I am going to substitute y of n from the convolution sum expression, that is summation n is equal to k, summation k is equal to minus infinity to plus infinity x1 of k into x2 of n minus k of z power minus n. Okay, now I am going to interchange the limit. First I am going to write the k limit, summation k is equal to minus infinity to plus infinity x1 of k, and I am going to apply only n limit for the where n we have only x2 only we have n, and z power 1. I am combining the two. Summation k is equal to minus infinity to x2 of n minus k z power minus n. Already same thing we derived. So how to derive this one? We have to assume n minus k is equal to some variable. N minus k is equal to assume as some m variable, and substitute if n minus k is equal to m means n is equal to m plus k. If we substitute that one, and after that if you simplify, we'll get it x1, will get it, that is x2 of m into z power minus m, and also we are going to change the limit, we'll get this expression. Correct. And also in addition to that z power minus k. So if you compare this expression with the z transform definition expression, we can write directly this is x2 of k, z transform of x2 of k. Correct. Z transform of x2 of k, and remaining expression is summation k is equal minus infinity to plus x1 of k into z power minus, that also we can write directly, that is also x1 of k z transform. So multiplication of x1 of z into x2 of z, this is only our statement. Correct. Convolution of two sequences z transform is multiplication of their z transform, that is x1 of z into x2. We proved. Understood? The remaining properties we'll see next class.